Is the standard normal distribution a probability density function? Well, what we're going to do is take a look at e to the minus x squared over 2 dx, and notice that this is if mu were 0 and the standard deviation were 1. The only difference is we don't have the 1 over square root of 2 pi out front. So let's go ahead and take a look at what this integral is. Remember, we cannot integrate this because this doesn't have a finite form. But what we can do is do this sort of trick where we square it. We take e to the minus x squared over 2 dx and multiply it by minus infinity to infinity of e to the minus y squared over 2 dy. And the reason is we want to find out what this is equal to. And we can't integrate this because we don't have any du out below, so there's no nice antiderivative function. We have to actually make up a function. So I'm going to multiply it together. And what I get is a double integral. I'm sort of glancing some things such as called Fubini's theorem and some others that allows me to do this. But we'll just pretend we can. And this is where we can go ahead and use some polar coordinates. If I switch this to polar coordinates, x equals r cosine theta and y equals to r sine theta, we can replace this then by r cosine squared theta minus r sine squared theta. Sine squared theta plus cosine squared theta is 1. And we get e to the minus r squared over 2. And if you remember from your calculus 3 days, the Cartesian coordinates become r dr d theta. Now, since I'm going over the entire plane, my r's are going to go from 0 to infinity. Actually, r is going to go from 0 to infinity, and then my angle around will be from 0 to 2 pi. So my r's go out, and I'm going out all the way around from 0 to 2 pi. Well, now that I have e to the minus r squared over 2, the derivative of minus r squared over 2 turns out to be r, or actually minus r. And so I'm going to have the integral from 0 to 2 pi of e to the minus r squared over 2 with a negative sign out front, going from 0 to infinity d theta. If I integrate from, there's no theta in here, and I'm just going to go ahead and write this as 2 pi. And I really need to look at this as an improper integral. So this will be the limit as b goes to an infinity of negative e to the minus b squared over 2 plus e to the 0, which is 1. Well, this some large negative number, this will approach the 0, and so what we're left with is 2 pi. Well, what that means is that because I multiplied this by this to get 2 pi, that must mean if I just take one of those, I've got minus infinity to infinity of e to the minus x squared over 2 dx must be equal to the square root of 2 pi. So in order to make this a PDF, I need to go ahead and multiply out square root of 2 pi e to the minus x squared over 2 will now be a valid PDF. Sometimes we write this as f of x, and the parameter is 0 mean and 1 standard deviation. And if this is the PDF, the CDF, we can represent this as phi of z as equal to minus infinity to z of 1 over square root of 2 pi e to the minus y squared over 2 dy, sort of a dummy variable. And so this right here then becomes f of y 0, 1. So indeed, this does become a valid CDF. Now, if you have some other standard normal, like say you wanted to have f of x mu sigma, that will be 1 over square root of 2 pi sigma e to the minus x minus mu squared over 2 sigma squared. And you can change variables just by using z equal to x minus mu over sigma to get it in the form of the standard normal distribution there.